Okay, let's resume part 2 of section 1.2, which is computing limits. Now, as we said, here we have two methods to solve this question. The first method is factoring, where we have limit when x goes to 2 of x squared minus 4x plus 4 divided by x squared plus x minus 6. According to factor theorem, since we substitute x equal to 2, we will get 4 minus 4 plus 4. And sorry, 4 minus 8. 2 times 4. 4 minus 8 plus 4 divided by 4 plus 2 minus 6, which is 0 over 0. According to factor theorem, since x equals to 2 is a 0, then x minus 2 must be a factor. And to get the second one, we said x squared over x, which is the first by first. That will give me x. And the last, which is plus 4, divided by the last here, which is minus 2, so you will get minus 2. Same thing here, x minus 2 is a factor, and x squared by x is x, and minus 6 by minus 2, it's plus 3. So x minus 2 will cancel with x minus 2, and you will get 2 minus 2 over 2 plus 3. That is 0 over 5, which is 0. Method 2 will be by synthetic division. So if I divide the first polynomial, which has coefficients 1, minus 4, plus 4, I'm speaking about that one, dividing by 2. So that's 0, 1 plus 0, it's 1, 2 times 1, it's 2, minus 4 plus 2 is minus 2, 2 times minus 2 is minus 4, so that will be 0. And dividing the denominator, which has coefficient 1, 1, and minus 6 divided by 2. So that will be 0, 1 plus 0, it's 1, 2 times 1, it's 2, 1 plus 2, it's 2, 2 times 2 is, so it should be 1, 1 minus 6, well, dividing by 2, 1 plus 2 is a 3, 2 times a 3 is 6, so that will be 0. So we will have limit when x goes to 2 of x squared minus 4x plus 4 divided by x squared plus x minus 6. When we divide, that will go, when we divide this one by x minus 2, we will get the result of the division, which is x minus 2. When we divide the denominator by x minus 2, we will get x plus 3. So when we substitute, it will be 2 minus 2 over 2 plus 3, which is again 0 over 5, which is 0. Now, same thing here. By factoring is the first one. We have limit when x goes to 1. I have 3x squared minus x minus 2 over 2x squared plus x minus 3. According to factor theorem, when we substitute x equal to 1, we will get 3 minus 1 minus 2 over 2 plus 1 minus 3, which is 0 over 0. So x minus 1 must be a factor, and to get the second one, it's a 3x squared over x, which will be 3x. And minus 2 divided by minus 1, which is plus 2. And here I will have again x minus 1 is a factor, and 2x squared over x, it's 2x minus 3 over minus 1 is plus 3. So x minus 1 is cancelled with x minus 1, and you will get 5 over 5, which is equal to 1. Now, second method, by using synthetic division, we could say limit when x goes to 1 of 3x squared minus x minus 2 divided by 2x squared plus x minus 3. If I divide the numerator by 1, I have 3 minus 1 minus 2, so 0. 3 plus 0 is a 3, 1 times a 3 is a 3, that is a plus 2, 1 times 2, it's 2, so that will be remainder is 0, and the result of the division will be 3x plus 2. When I divide the denominator, so it will be 2, 1 minus a 3. If I divide it by 1, 2 plus 0, it's 2, 1 times 2, it's 2, 1 plus 2 is a 3, 1 times a 3 is a 3, so that will be 0. So that will be 2x plus 3. When you substitute 1, you will get 5 over 5, which is equal to 1 again. Similarly here, using factoring, we have limit when x goes to minus 1 of 2x squared plus x minus 1 over x plus 1. Now, when I substitute, I will get 2 minus 2 over minus 1 plus 1, which means minus 1 is a factor, so x plus 1 minus 1 is a 0, means x plus 1 must be a factor. So the second one, we will get it 2x squared divided by x, which is x, and minus 1 divided by plus 1, it's minus 1. Again here, x plus 1 is a factor, so to get, sorry, we have only x plus 1. So x plus 1 will cancel with x plus 1, and you will get the result is minus 2. Method 2 is by synthetic division. So if you have limit when x goes to minus 1 of 2x squared plus x minus 1 divided by x plus 1. So we are dividing by minus 1. So I have 2, 1, minus 1 are the coefficients. 2 plus 0, it's 2, minus 1 times 2, it's minus 2, 1 minus 2, it's minus 1, minus 1 times minus 1 is plus 1, so the remainder is 0. The result of the division will be lower at 1 degree, so it will be 2x minus 1. When you substitute, you will get minus 2 minus 1. Just a second. I have here 2, 1 minus 1. So result is okay. That's 2x plus 1. When x goes to minus 1, it will be minus 2 minus 1. Okay. And here we have a mistake here. Here we have, this is 2x, not x. So when we say x goes to minus 1 means x plus 1 is a factor. For the second one, we have 2x squared over x, which is 2x. So that will be limit when x goes to minus 1 of 2x minus 1, which is equal to minus 3. So that is now minus 3. Okay. Now, Now we need to use synthetic division, definitely. Synthetic division, we could say, again, I will do it by two methods. The first one, of course, above, I need to divide by 2. So I have degree is what 3 is 1, degree 2 is 3, degree 1 is minus 12, then 4. So that will be 0. 1 plus 0, it's 1. 2 times 1, it's 2. 3 plus 2, it's 5. 2 times 5, it's 10. So that is minus 2. 2 times minus 2 is minus 4. So that's the remainder is 0. Which means I can write the polynomial t cubed plus 3t squared minus 12t plus 4. I can write it as the divisor, which is t minus 2, that comes from here, times the result of the division. We decrease it 1 degree, so it will be t squared plus 5t minus 2. So I can now say limit when t goes to 2 of, instead of t cubed plus 3t squared minus 12t plus 4 divided by t cubed minus 4t, I could say, according to the factor theorem, that is t minus 2, which is the divisor, times the result of the division, which is t squared plus 5t minus 2. Regarding here, I will take t common factor, so it will be t squared minus 4. Then I will say that t goes to 2. This is the same t minus 2, but I need to complete the factoring the denominator. Completing the factoring of the denominator, it will be square root of the first minus square root of second, square root of the first plus square root of second. Now t minus 2 will cancel with the t minus 2. So you will get here 4 plus 10 minus 2 divided by 2 times here you have wait a minute. Yeah, 2 plus 4 is 6. Okay. Let me just double check it. I have taken t common factor. So it will be t squared minus 4. So it will be t minus 2 times t plus 2. So that will be equal to 8 plus 4, which is 4 plus 10, it's 14 minus 2, which is 12. I think there is a mistake somewhere here. Wait a minute. T minus 2, this is t squared plus 5t minus 2. We are taking t common factor. So this will become t squared minus 4. So it will be t minus 2 times t plus 2. Here is the mistake. T plus 2. So that will be equal to 2 times 4, which is equal to 8. Now that is perfect. Divide by 4 is 3. Divide by 4, it's 2. That's one way. The other way, when you have limit when t goes to 2 of t cubed plus 3t squared minus 12t plus 4 divided by t cubed minus 4t, you will divide both by the same factor, which is t minus 2. So you will divide here by 2. The first polynomial as it is, this is 1, 3, minus 12, 4, there is nothing missing, so that will be 0. This is 1, 2 times 1, it's 2, 3 plus 2, it's 5, and 2 times 5, it's 10, that will be minus 2. 2 times minus 2 is minus 4, so the remainder is 0. So when you divide, you will get lower at 1 degree, so it will be t squared plus 5t minus 2. Now, the second one, again, you are dividing by 2, but coefficient of t cubed is 1. Coefficient of t squared is 0. Coefficient of t is minus 4. Constant is 0. So any missing term must be replaced by 0. So it will be 1 plus 0, it's 1. 2 times 1, it's 2, 0 plus 2, it's 2, 2 times 2, it's 4. That will be 0, 0, 0, so that's the remainder. When you lower it 1 degree, it was degree 3, it becomes degree 2, so it will be t squared plus 2t plus 0. Now, when you replace 2, you will get 4 plus 10 minus 2 over 4 plus 4, which is again, it is a 12 over 8, which is divided by 4, it's a 3. Divided by 4, you will get 2. Actually, it's the same idea, but repeated in 2 different ways. Same thing here. We will say I have t is going to 1, t cubed plus t squared minus 5t plus 3. I have here t cubed minus 3t plus 2. So I'm going to divide the first one by 1. So I have 1, 1 minus 5, 3. There is nothing missing. So this is 0. 1 plus 0, it's 1. 1 times 1, it's 1. 1 plus 1, it's 2. 1 times 2, it's 2. Minus 5 plus 2, it's minus 3. 1 times minus 3 is minus 3, so that will be 0. And the second, which is in the denominator, I'm dividing by 1, but be careful, I have coefficient of t cubed is 1. The second degree is 0, then minus 3, then 2. So 1 plus 0, it's 1. 1 times 1, it's 1. 0 plus 1 is 1. 1 times 1, it's 1. Minus 3 plus 1, it's minus 2. 1 times minus 2 is minus 2. So adding up, it will be 0. So that will be limit when t goes to 1. It will be, when we divide the numerator, the result is t squared plus 2t minus 3 by lowering 1 degree. When I divide the denominator, the result will be, again, t squared plus t minus 2. But when I substitute, again, I get 0 over 0. So I could apply synthetic division again, or use factoring. If you apply synthetic division again, that will be 1, 2 minus 3. We are dividing by 1. So this will be 1. Plus 0, it's 1. 1 times 1 is 1. 2 plus 1 is 3. And 1 times 3 is 3. So the remainder is 0. So we will get t plus 3, lowering 1 degree. Same thing here. 1, 1 minus 2, so that will be 0. 1 plus 0, it's 1. 1 times 1, it's 1. 1 plus 1, it's 2. 1 times 2, it's 2, so that's 0. So I'll get here t plus 2, which means it is 1 plus 3, 4, and 1 plus 2, it's 3. Now, next question. We need to multiply by the conjugate, as we said before, square root of x squared plus 4 minus 2 over x. I multiply by the conjugate to get rid from the root. The conjugate will be square root of x squared plus 4 plus 2. That will be x times square root of x squared plus 4 plus 2. So that will be equal to limit when x goes to 0, square of the first minus square of the second, square of 2 is 4. So 4 minus 4 is 0, so you will get x squared over x square root of x squared plus 4 plus 2. Now, that will be equal to limit when x goes to 0 of x over square root of x squared plus 4 plus 2, which means it's 0 over 4, which is 0. Same question actually. It's limit when x goes to 0 of 2 minus root x plus 4 over x. That will be equal to limit when x goes to 0 of 2 minus root x plus 4. When we multiply it by the conjugate 2 plus root x plus 4, this is x times 2 plus root x plus 4. So that will be equal to limit when x goes to 0. Square of the first is 4 minus square of the second, which is x plus 4. This bracket is a must, otherwise you will do a mistake. So that will be limit when x goes to 0. 4 minus x minus 4 over x over 2 plus root x plus 4. Again, the brackets here are must. So you will get this is equal to limit when x goes to 0. Above I will have minus x, below I'll get x times 2 plus root x plus 4. Now x will cancel with x, and you will get limit when x goes to 0 of minus 1 over 2 plus root x plus 4. So when you substitute 0, you will get minus 1 over 4. 0 plus 4, square root of 0 plus 4 is square root of 4, which is 2 plus 2, which is 4. That's the question. Here we have to understand our function. We have 0 and we have 2. Before 0, it's x minus 2. Between 0 and 2, it's x squared. After 2, it's 2x. So when he asked me about limit when x goes to 0 for the function, I should tell him before I have 0 from left and 0 from right. This is left of 0, this is right of 0. So I need to consider limit when x goes to 0 from left first, and that will be limit when x goes to 0 from left, which is x minus 2, so I'll get minus 2. And then I need to consider limit when x goes to 0 from right, and that will mean limit when x goes to 0 from right, I have x squared, so that will be 0. So from here, since they are not equal, we could say limit when x goes to 0 for the function of x does not exist because they are not equal. B, he wants limit when x goes to 1 for the function. 1 here entirely inside the region. So that will mean limit when x goes to 1, our function will be just simply x squared, so it will be 1 squared, which is 1. Now for C, he is asking about 2. So again, 2, I can approach 2 from left and from right. So I should say to solve limit when x goes to 2, I need to consider first from left. And if I consider it from left, I will get x goes to 2 from left means it is x squared, so I'll get 2 squared, which is 4. And limit when x goes to 2 from right, it will be my function. If I approach 2 from right, it's 2x. So it's 2 times 2, which is again 4. Since they are equal, we could conclude limit when x goes to 2 for the function f of x is equal to 4. This will end up our section computing the limits at a constant number, and the topic of the next class will be limit at infinity. Thank you for listening.